You're listening to the N2K Space Network.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
Satellites haven't changed much in their basic design since we started launching them in the 1950s. Think about it, right? They go into their predetermined orbit, they live to a short life expectancy, and then they burn up in our atmosphere on reentry. But what if there was a different approach that could help resolve limitations, especially now that things are getting awfully crowded in LEO? Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Portal Space Systems says they're solving the need for mobility in space with their Supernova spacecraft. And I spoke to Portal CEO Jeff Thornburg at Spacecom 2025 all about their new approach to satellites.
I'm Jeff Thornburg. I'm the CEO and co-founder of Portal Space Systems. I started out in the U.S. Air Force and was active duty for about 7 years. Got my bachelor's and master's in aerospace engineering. Went to work at the Air Force Research Lab where I got to develop rocket engine technology for the Air Force and NASA. I followed that up. I worked for a company called Aerojet for about 5 years doing similar things. Went out to NASA Marshall and worked on the Ares rocket program and upper stage. Then got this great phone call from Elon Musk and said, why don't you come check out SpaceX? So I went out in 2011 and started a 5-year adventure with SpaceX where I was hired to develop the Raptor engine and got to work with a great propulsion team and team at SpaceX in general, and then was the second head of propulsion at SpaceX and worked on the Falcon Heavy and the Falcon 9 reusable and Crew Dragon. And this is all like the 2011 to 2016 timeframe when we were really developing all of the stuff that people see now. Really loved my wife and daughter. We wanted to hang out, so we decided to see each other again. And I left SpaceX in 2016. And then I had some really cool things happen after that. I got a chance to meet Paul Allen and work for him the last 2 years he was alive. I started my first space company as an experiment, but then the pandemic kind of derailed that. But I learned a lot of great stuff. Amazon asked me to come lead engineering and manufacturing for Kuiper, which is what moved me and my family to Seattle. And then after leaving Amazon, decided I really wanted to get back into entrepreneurial space. And my co-founders and I started Portal Space in the fall of 21 to build a highly maneuverable spacecraft for military and commercial missions. So there's 29 years as quickly as I could make it.
I know. You did not need to speed any of that up because I was going to say, I'm pretty sure we could spend hours just getting into any part of your career. You've heard this all before, I'm sure. You are just an exemplary builder of incredible things. So I'm just really thrilled that I get to speak to you a little bit today. Oh my goodness, working on the Raptor. I mean, that alone, where does one even start with that? I mean, I'll ask the soft question of how do you feel about it now, looking back on this and what it's doing? I mean, that's got to be pretty freaking incredible.
Oh, wow. Yeah. I mean, somebody asked me today, like, how did that start? Even if it was a friend of mine I've known since college. I saw him here today and I said, well, It started because I was fortunate enough to work a program for the Air Force and NASA that was really the precursor to what became the Raptor engine. And so my career kind of came around full circle. And when I went to work at SpaceX, I was pretty much a one-person show to start.
Wow.
And then after a few months, I got to build a team, and we started to develop the technology for Raptor. And, I didn't do any of this by myself, but it was a great, talented group of people. I was able to bring my experience of technology development, and I think as that kind of snowballed and we got moving on the program, then we're meeting in SpaceX and talking about what should Starship look like. And it had a lot of different names before Starship. But to answer your question, what's really cool to watch Starship fly is you see 33 Raptors on the first stage.
Yep.
And, I was noodling on those packaging designs for the first stage of how the engine should fit, many, many years ago. Wow. And to see what the team has done since then, to see it flying, to have been a small part of that I probably could have retired there and been like, okay, I'm done. But I wasn't done yet, but it was really, you get a lot of satisfaction. And I get a lot of enjoyment out of talking to the folks I still know there every time it flies. Yep. And we commiserate about the early days versus where they are now. So it was an amazing opportunity, and it was a great way for me and that team to make a small mark in the history of space exploration.
It's every time I listen to a broadcast where they're like 33 Raptor engines ignited, it's like, that's got to feel great. I can only begin to imagine. You got the entrepreneurial bug, so to speak, and you've got your company now. Can you tell me a little bit about sort of how you got that entrepreneurial bug, how you got started as an entrepreneur?
Yeah, it's great that you asked that, because where my brain was going reminiscing about Raptor is that when I left SpaceX, I'd gotten to check all the boxes of things I wanted to do as an engineer.
Yeah.
And even a technical executive, because SpaceX was really my first VP level job as an engineer. And when I left SpaceX and I checked those boxes, I'm like, what am I doing now?
What are you building next, right?
And what's the next project?
Yep.
And I think the excitement there was moving on to finding what that next thing is. And I'd spent a career working launch vehicle and propulsion, and I had always in the back of my mind wanted to develop spacecraft that took advantage of that now low cost and more prevalent and more capable launch vehicle system. And so I didn't start there with what we're building now at Portal with a highly maneuverable spacecraft, but the desire has been there since I left SpaceX. And then I really needed to go out and learn more from a bunch of different industries and experience so that I could be where we are now as a team, actually to execute on that. So, when you accomplish everything you thought you wanted,
where do you go from there?
It took me a few months to be like, okay, what do I do now? And then fortunately for me, Paul Allen was like,
well, that's quite a person to be.
I want some of that. Can you come help us do stuff? And I got to work with a great team there. And it helped me kind of figure out, okay, when he passed away, then I had another moment of, everybody always asks, so when these billionaire founders that are running these space companies, when something happens to them, what happens then? Well, I got to live that. It's not fun. Oh. However, it provides yet another opportunity. So I think my long answer to your short question is, sometimes things work out great. Sometimes they work out the way you weren't expecting, but ultimately it was able to give me the right experience to go do what I really always wanted to do before I ended my career, which is let's go fly stuff on orbit in a way that's going to push humanity's capabilities into the solar system better.
Yeah, let's talk about what you all are building, because so when I was doing my mandatory host research, just looking at the sizzle reel and the stuff, I want you to describe what you all are building, but to me, my jaw just dropped. So for our audience who haven't seen the incredible things you all are working on, can you please tell me about it?
Sure. So our main product now is called Supernova, and it's a small spacecraft with a ton of maneuverability. But what does that even mean?
Yeah.
Well, we've spent decades building spacecraft that go up on a rocket and they sit in the same place in orbit for their whole life.
Right.
And they have just enough propulsion and gas in the tank to keep that position, to relay data, take pictures, whatever they want to do. So we haven't reinvented spacecraft since the 50s in this country, really. So everybody's wanting to have more capability on orbit, meaning I can move from a lower altitude orbit to a higher altitude orbit and back. Maybe I can refuel, maybe I can grab something, maybe I can deorbit something, maybe I can pick up trash. How do you do all that? Well, you've got to move around like you see in science fiction.
Yep, that's exactly what it made me think
So
of,
the excitement to me was, how do I now make and work with a team that can make that science fiction reality? So we innovated a new propulsion system that is a concept from the 1950s that the government's worked on off and on since then, called solar thermal propulsion. And we took this thermal propulsion system and we built an efficient bus structure around it, put a very flexible payload deck on it. So now we can offer industry a very efficient, maneuverable platform to go between orbits and back and be very on rapid response. Either it's pre-positioned on orbit, it's launching on rapid launch vehicles, but it provides the customer the mobility that they're looking for both a lot of defense missions, obviously, but also a lot of upcoming commercial missions because more maneuverability is required now. Even if you're just providing internet to the ground, you're now dodging more spacecraft and junk in LEO than you ever were before, which is taking more gas, more propulsion capability to do that.
Yeah, and I mean, so first of all, for folks who haven't seen what this looks like, it looks visually very different from what I think a lot of us think of when we think of spacecraft. So just it's visually extremely striking. But also, I mean, I was reading something about like to sit from LEO to GEO to cislunar, just that kind of maneuverability. I mean, that just sort of blows my mind. That's quite incredible. What that would open up in terms of possibilities for industry, for governments, I mean, my goodness, there's a lot there.
Yeah, and then when you add refueling capability on top of that.
Built in, right?
Built into our current capability, you can go from just offering a lot of delta V or a lot of maneuverability and range to unlimited.
Yeah.
And so I think when we talk about the future of spacecraft on orbit, that's what I had envisioned for Supernova at the beginning, where you really have to rethink it from the ground up to offer these capabilities. And people often, there's an old tired trope in entrepreneurship about creating the next killer app or inventing the iPhone for space.
The new paradigm, right? Yeah.
But I think we really have an opportunity with these highly maneuverable platforms like Supernova. I don't know all the missions or needs that are out there for people, but I can tell you that everything everybody wants to do in space is all tied to maneuverability and delta V on orbit.
Yeah.
And the more I can offer, along with high thrust, I mean, if you can now go from low Earth orbit to GEO in a day, you can go from MEO to LEO in a couple of hours. Now you've completely changed what's possible from both a defense and a commercial standpoint in the future.
We'll be right back after this quick break.
Cyber threats are evolving every second, and staying ahead is more than just a challenge, it's a necessity. That's why we're thrilled to partner with ThreatLocker, the cybersecurity solution trusted by businesses worldwide. ThreatLocker is a full suite of solutions designed to give you total control, stopping unauthorized applications, securing sensitive data, and ensuring your organization runs smoothly and securely. Visit threatlocker.com today to see how a default deny approach can keep your company safe and compliant. And now, a message from our sponsor, Zscaler, the leader in cloud security. Enterprises have spent billions of dollars on firewalls and VPNs, yet breaches continue to rise by an 18% year-over-year increase in ransomware attacks and a $75 million record payout in 2024. These traditional security tools expand your attack surface with public-facing IPs that are exploited by bad actors more easily than ever with AI tools. It's time to rethink your security. Zscaler Zero Trust plus AI stops attackers by hiding your attack surface, making apps and IPs invisible, eliminating lateral movement, connecting users only to specific apps, not the entire network, continuously verifying every request based on identity and context, simplifying security management with AI-powered automation, and detecting threats using AI to analyze over 500 billion daily transactions. Hackers can't attack what they can't see. Protect your organization with Zscaler Zero Trust and AI. Learn more at zscaler.com/security.
You know, the seeds of this started decades ago. So what has enabled this to happen now?
Well, I think if I take a quick half step back, I'm a firm believer in, if somebody said, Jeff, what's the future of propulsion in your lifetime? I think it's systems like nuclear thermal propulsion, where you've got a nuclear reactor, it's heating a fuel, you're throwing it out the nozzle, it's very simple, it's not got combustion, and it's very efficient in ways that chemical isn't. I can't go get a reactor at Home Depot yet.
Not yet.
But so until I can use that same thermal cycle with concentrated sunlight. And that's really why our spacecraft looks the way it does, as you described it earlier, is because we're concentrating sunlight, we're heating up a heat exchanger, and we can do that now because of advancements in additive manufacturing, which I've got to work on for aerospace for the last 12 years, and with new alloys and new powder metallurgy for those alloys that facilitate 3D printing. And I think I've just been fortunate enough to work a lot of materials engineering along with aerospace development, hardware engineering over my career. And when you can marry those two, now you can really change what people didn't think was possible to now what's possible. And the fewer parts, the more simple you make it, the more reliable it is. I mean, I don't just want to have a cool tech that could do one-off stuff. I wanted to have a multi-year platform that we're now talking about what are we getting done, not can we get a spacecraft to do X, because that's kind of where we are right now. And you asked about the entrepreneurship bug and why that really happened. And it was really because after I left SpaceX, I didn't know what I wanted to do. And I thought, what's the next big challenge that's space-related? Build my own space company. And, you know, entrepreneurship is not for the faint of heart, because you're going to fail a few times before you get it right. And I've gone through failures, I've gone through successes, and I think what got the bug is I got to work with a lot of smart entrepreneurs and other folks in the space industry. I've been a part of incubator programs like the Creative Destruction Lab at the University of Toronto. And it's kind of rewired my brain more of and kind of accelerating my MBA business mindset along with space. Because my partners and I really want to make a business that's viable. And space companies and new starts have a hard time closing that business case and keeping it viable in something that could grow massively. And there's a lot of things that working against any entrepreneur, but I can't think of a bigger challenge in space, which that's my problem. I got addicted to big challenges early in my career, and now I can't seem to get away from big challenges, but that's okay. It's
a worthy challenge. Since we're talking about this, I love asking folks like yourself about your attitudes around risk and embracing failure. You touched on that, but it's a big part of your life and how you've learned. So any words of wisdom on that for folks who, you know, we often talk about, you know, embrace failure, but that is a lot easier said than done. Same thing with embracing risk and taking on risky ventures like what you're doing. What are your attitudes around all that?
Yeah, I think the way I look at risk is been shaped by a few different things. I was lucky enough to be a technologist at AFRL first. So I always have this technology development lens to try to mature new innovations and not just be focused on what's going to make money. Because I really do want to solve problems, because at my heart, I'm an engineer, right?
Right.
So I think with the risk question, you have to ask yourself, what is smart risk versus dumb risk? And I think a lot of companies make dumb risk calls because they get rushed. They want to get a product to market faster. They want to meet a timeline. Their investors are pressuring them, or they're pressuring themselves.
Huge pressures, of course.
And they throw a Hail Mary going, hopefully it works. Space is unforgiving. If you're throwing Hail Marys, you're probably going to get bit. And when I did the technology development for space earlier in my career and then got to work at SpaceX and other things, I think you have to go and find the best people in their area and listen to them, and then architect risk reduction within your development that gets to the right price point and speed, and you're not sacrificing and making guesses when you go on that first flight. If something happens, I'm okay with that, especially if it was an unknown, because that's what flight's for.
Yeah.
But if I'm failing flights for things that I should have known better on, then I probably shouldn't be in that type of job.
Yeah.
And those are things you got to learn, which means businesses and the government have to let people do that. And when you look at the SpaceXs of the world, typically the mindset is go make mistakes, go break things, go learn as fast as possible, but don't do it a second time. Because when it's happening a second and third time,
you didn't learn.
Then there's some fundamental flaws in the engineering process and how you're thinking about risk and how you're really mitigating. But I'm giving you a biased answer because I've become so used to risk that things that don't seem that risky to me sometimes seem very risky to other people. But I'm very much a proponent of 75 to 80% of the solution and move forward. If you're waiting for the 100% answer, you're going to run into the same problems that a lot of government programs have, which your analysis paralysis, multi-years, and you have this standing army of people that you're paying
who want to get stuff done.
They want to get stuff done, and it's costing you money. You've got to get to the ultimate test is always flight, and you should try to get there as fast as possible, but just don't make rushed, dumb risk calls along the way.
Yeah, I would also imagine that there, something factors in here is also the motivation of the people that you're working with. If it takes too long, then people are sort of waiting for that payoff. It's not really happening. Yeah, it's that embracing that kind of attitude around risk and failure. Does that involve? I'm always curious about that payoff between moving fast, but also making sure that you're not moving too fast. How do you make sure you're slowing down a little bit to be deliberate without going too slowly?
Yeah, that's a great question because I tend to have some muscle memory for that based on my life experience. And I get asked about this a lot, but I try to bring in myself and other subject matter experts that have a real feel for how the system should operate.
Understood, yeah.
And I think that approach, it's really an experience-based thing because you can't engineer everything all of the time. You have to bring in some experience into that engineering process to say, is this too much or too little risk? And I guess how I would maybe quantify that a little bit is it's a combination of people experience with how good an engineer you are. So where I'm going is when I was a younger engineer, I used to think anything could be overcome by just smart thinking. And when I became a better engineer, I realized everything was really a people problem. And what that means to me is you have to be able to read your team, you have to be able to listen, you have to be able to not be influenced by things that are going to have you make poor decisions. You have to absorb all that information as a subject matter expert or an executive leader to make the best call. And I think when people ignore things in data or conversations, that's normally my red flag whenever I would be consulting a business or working in an organization is those things should immediately be interrogated deeply because that's where the failures are going to come from. And that doesn't mean you still won't have failure, but that's how I minimize failure. Is the human psychology and the interaction, is that vibing like it should be? There's a little bit of a feel for that.
Yep.
And there's also a lot of feedback coming from your team. But when you can feel when your technical team's really engaged and doing their best work. And once you experience that, that's what you're chasing the next time you have a project that's that complicated. So there is some engineering smarts that go into this, but I found later in my career, but it's that human element that I'm still working to master. But if you ignore that, you're definitely going to have more problems than if you embrace that. And engineers socially are terrible at that traditionally. And I am one. I'm
married to one. I'm the daughter of one. So you're
right. So
yep.
I mean, I don't think I'm talking out of turn.
No.
I was even that same way.
Yeah.
And I think the military was able to really focus me in on the people and the leadership aspect in ways I wouldn't have.
How does one develop that? Exactly.
Yeah. If I had just gone to school and become an engineer and then found myself into leadership, it wouldn't have been the same as it is now because I had 200 enlisted people working for me when I was working on KC-135 tankers as a lieutenant that were teaching me how to be a leader.
Yeah.
And that experience stuck with me my whole career.
It certainly has carried you really far. And I was so curious to hear your thoughts on that. So Thank you for validating a theory that I had in my head. All right, so that was a bit of a selfish question on my part, but thank you. I appreciate that. So let's go back to Portal just real quick. I feel like I would be remiss if I didn't ask about potential timelines for what you all are developing. I'm sure that is the most hated question in the universe, but tell me about it. Like, what are you thinking for timelines here?
Yeah, so we've been in this very fortunate position of having great customer interaction, especially with the Department of Defense the last couple of years. So we're very much into building all of the subsystems for our first demonstration spacecraft this year. We opened our facility to customers January 15th, just a couple of weeks ago.
Wow.
Had some of our first customer visits. Our subsystems will start coming into our Bothell, Washington facility for integration and testing. And that's going to be 2025 for us, is subsystem build, subsystem testing, validation. And then by the end of the year, we're integrating the first spacecraft, so they're ready to fly in 2026. So
wow,
that's what the next year or two looks like for me and my team.
That is fast. So I appreciate you taking the time to talk to me about it, because I'm sure you all are crazy busy. Jeff, this has been a serious pleasure. I really appreciate your insights and your time. If there's anything you want to leave the audience with before we close out, by all means, you have the last word.
I would say to anybody interested, especially the younger folks in the audience that are starting their career, is don't get so wrapped up in where you think you need to go, but embrace that it's a process. And some jobs are going to be amazing, some jobs not so much, but know where you want to be and have everything kind of trending in that direction. And I guess I give my wife a lot of credit, because my wife is a horse trainer. So a very different world than
totally
aerospace engineering.
Yeah.
But the quick metaphor is, when you're learning how to ride a horse, it's very complicated, because some days it goes very well and some days it doesn't, because you're on a horse, another animal. And the key is, it doesn't matter how many good days and bad days you have, only that you, in the end, are trending more towards where you want to be, than that every day you're exactly where you want to be. And so you have to really keep the end in mind. And that's been kind of a guiding principle of my career, and treating people well and how you want to be treated, and elevating a team to higher performance. I think those have been things that have stuck with me.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilby is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We'll see you next time.